Okay, so today we're going to continue with the demonstration that we've been doing, and probably finish it today. But something really bothered me about the design of this book class that we've had, and it's not absolutely wrong, but it's not absolutely correct either. So what we're going to do is we're going to finish it up by refactoring it. We're going to change some things. First of all, I'm going to do a demonstration to see what the shortcoming of this design is, and then we're going to go back and refactor it and fix it. To do that, what I'm going to want to do first is produce a book report. I want to produce a report that shows for each author how many books did they actually publish, all right, or in my collection at least. Remember that we've got this map here where we're mapping an author's last name to a set of books by that author. And we were successful in doing that and printing this out, but it's not pretty, right? Save and launch, there we go. So it's not pretty here. We've got Pratchett and then it's all one big giant line here. I don't want to do that. Instead, what I want to do is produce a nice little compact report here that lists Pratchett, Herbert, and then they publish 3 books, Herbert published 6 books or something like that, whatever it is, okay? But because I chose to represent the data as this mapping, right, this key value pair where the key is the author's last name and it's mapping to a set of their books, it's going to be really, really easy to produce this report. All I need to do is iterate over each key, right? That is a last name, right? And for each one, find the set of books and find the count in that set, right? Then report it by printing it out. Right? That's going to be actually fairly easy because of the way that we chose to represent this data. Right? So I'm going to go ahead and iterate over each one of the keys. For string last name in the collection book map, now I need to get the keys out of the book map. Remember, the book map is mapping strings to a set of books. So I want a set of all the keys. Luckily, there's a way to do that. Dot key set. Right? Key set is going to give me a set of all the keys in that map. All right? If you were in Python and you were using dictionaries, you could just iterate over the elements because by default, it's the keys that are the elements. If you wanted to iterate over the values, guess what? Dot values. It's exactly the same as in Python. If you wanted to iterate over all the key value pairs, in Python, you've got a nice convenient syntax to do that. For k, comma, v in the collection dot, items, something like that. Then you can go ahead and do that. But we don't have that nice syntax here in Java. Instead, what you'd have to do is you'd have to pull out key pairs, or I forget how to do it, but I don't want to do it, right? This is going to be just as convenient for us. So for each last name, I want to get the set corresponding to that last name. So bookmap.get last name. Right? What that's going to do is that's going to look up the set of books by that author. Right? And I'll just call it, do I have S here? Yeah, S. Right? Now I need to determine how big that set is. So if we've got a set, how do we determine the size, or a list, a set, or even a map here? How do we determine the set, the size of that collection? S dot size. Right? I'm going to go ahead and pull that out into a variable here, int n. Now I'm ready to report. I've got their last name, and I've got the number of books that they've published. Is n a great variable name, first of all? Probably not. What does it represent? Number of books. I like that variable name a lot better. Right? We've been seeing a lot of questions that have popped up on Piazza or in person or during office hours where we've had to look at those variables and say, what the hell does that variable stand for? Because it's a terrible variable name, right? And once we've understood what the variable name stands for, then it kind of clicks, right? That, oh yeah, that's an index. I should be using it as an index, right? From binary search or something. So style is not just, one of those check boxes that you check off, yeah, I've got good style, or I've got bad style. Bad style leads to bad code and bugs, right? It's that important. Right? So let's go ahead and print this out, system.out.println. Or let's go ahead and go with a formatted style here. And I'll go ahead and print out their name. In fact, I'll print it out in 20 columns of data so that it all lines up. And %d, and then end the line, their last name, and the number of books that they've published. There we go. Let's go ahead and run that version now instead. All right, looking a little bit better, right? Pratchett wrote 4 books in my collection. Gene Orwell here has 1. Robert Heinlein 2, et cetera, et cetera. Herbert has 7. Wait a second, he only wrote 6 Dune books, right? This is what was bothering me, and we'll come back to this in a second. But we can also make this a little bit prettier, right, if we wanted to. What I'll do is I'll left justify that string so that it's over here on the side. Otherwise, by default, it's right justified, right? And save this and run it. And you can see that everything lines up now nicely. Right? Same report, it's just a little bit different, more compact. Everything nicely lines up. All right, so Frank Herbert only wrote 6 Dune books in the main series. What was bothering me was, well, his son came along after he died and started writing some more Dune series books. His son is Brian Herbert, and the first one that he published is in 1999, Dune House Atreides. And I looked it up on Goodreads here. It had a 3.8 rating, so decent book by the community standards. All right. But what's happening with our report over here? Where is that being reported? It's being reported as Herbert, right? Is there a difference between Frank and Brian? Most definitely, right? But in the way that we've represented the data, just getting the author's last name here, right? And sorting it by author's last name, et cetera, is it respecting that idea? Nope. All right. Remember, we are online, so if you have questions, you can go ahead and post to the YouTube live stream here. So my first step here is to come back and reflect on how I represent a book, okay? First of all, a book has a title, right? It doesn't get any simpler than that. A title is just a string. It has a year. Well, I mean, there's a difference between being released in, January 6th, 1999 versus July 7th, 1999. So we don't have a lot of detail here, right? And also, it's an integer, right? What if it was published 700 years BC, right? What should we use for that? Negative 700? Okay, that makes sense. But was there anything published in year 0? No, there was no year 0. That's invalid. Right? So, all right. So maybe that could be improved somehow. Rating is the rating, right? Now, ratings on Goodreads go from 0 up to 5. So maybe we would want to have some sort of a data validation here on rating, saying that if you ever tried to create a book instance with a rating of -2, then we're going to throw that back at you as an illegal argument exception or something. Right? But what I want to focus on here is the author. I've got their first name and the last name. Now, for the data set that I've been playing with, that's enough. But is that enough, like if I wanted to actually produce a full system here, a full library system? No. What else does an author have? An author has a date of birth, date of death maybe, right? Poor Frank, right? What else? A middle name, right? Right, et cetera, et cetera. Let's just go ahead and winnow it down to what we have. A first name and a last name. What did I say on Wednesday? When you've got more than one piece of data, what should that be screaming out to you? Make a class. Right? A person as an author is one thing, right? With multiple pieces of data that represent that thing. Right? Let me refactor this and rethink this entirely by saying, well, I need an author class. But now let's think a little bit more generally, right? What if I don't know, an editor, right? Should I create a separate editor class for somebody who's an editor? Well, what if they're an editor and an author, right? And what if they're a publisher, right? An individual can publish, et cetera, et cetera. Probably want to think a little bit more generally here as a person, right? A class that represents a person. Now, they're not necessarily an author, so I'm not going to call their first name author first name. Instead, I'm going to have a string first name. There we go. String last name. And just for variety here, we're not going to use it, but I do want a date of birth. Date of birth. Think about that for a second, though. What is a date of birth? What is a date? What's a way to represent a date in your homework due tonight? How is an ISO 8601 formatted string? Yeah, we could do that. We could go string date of birth and then pretend that it's an ISO 8601 formatted string. What's an alternative? So what is today's date? February 10th, 2023. How many pieces of data was that? February, date, day of the month, and year. What is this screaming out to you? Make a class. Or better yet, what's the best question that you ask yourself in engineering? I've got this problem that I need. What's the first question that you should ask yourself in engineering? I've got this problem to solve. Excellent. Has somebody else already solved it? Can I pull an off-the-shelf solution to bring to bear to this problem so I don't have to work so hard? That's exactly what engineering is, right? We want that utopia where we humans can engage in, frivolity and recreation all the time. We want that Star Trek world where the machines take care of everything for us and don't kill us, right? All right, so is there an off-the-shelf solution? Absolutely. It's built into the language. Local date, date of birth. Right? You might have seen that in one of your labs. Right? Local date is built into the language in the java.time library. Okay? All right, let me go ahead and make all of these private. Now that I know what I want in my class, then I can go ahead and make them all private. Oops, space, space, space. I can rely on my magic GPT. It's not GPT at all. It's just something that's existed for 20, 30, 40 years, right? Auto code generation. I want a constructor here using the fields. Because I don't want the date of birth, I'll just go ahead and uncheck that, generate that. I can create a person based on their first name and their last name. The date of birth will by default be null, right? I want a toString method. So let's go ahead and go up to source, generate toString, yeah, and modify this so that it's string.format. And I just want a last name, first name. So %s, this dot last name, this dot first name. There we go. And be done with it. Come on. There. I'll also probably maybe want getters and setters. I can go ahead and do that by generating getters. Just getters, by the way. No setters. Why? Because I want this to be an immutable class. There. All that's left is to put the finishing touches up here of some nice documentation. Right? Represents a person. Right? This class represents a person. Go ahead and write an essay if you want. Keep it simple. Right? What about the rest of these methods? These are trivial methods. Any method that can be generated by an IDE is trivial, and at least for this class, we're not going to require documentation on it. We are done with this class. Now, let's use it. Instead of an author first name, last name, let's change this so that we have a private person, which is an author. Right? This is known as composition. This is something that we're going to more formally discuss after we talk about technical writing on Monday. But a class is composed of other classes. This book is composed of a string class and the person class. And then the person class is composed of two other strings. It's other strings and then another class. By the way, how do you think local date is actually implemented in Java? Let's find out by jumping into the class. Right? What do you see? Down, where is it? Here. An integer representing a year. A short, which is just 1 byte of integer, representing the month. Why? Because it's only 1 through 12. And then another short representing the day. Why? Because it's only 1 through 31. Right? Did we have to worry about that, by the way? No, that's called abstraction. That's one of the other key elements of object-oriented programming that we'll cover in more detail that we've implicitly covered up to this point. I don't have to worry about that, right? Just like math.sqrt, how does it actually compute the square root of 2? How? I don't know. Do you care? No, right? That's what abstraction is all about. The details are in the class. The details are in the function. Who cares? We just want to use it. I just want to use this local date here, okay? Go back to the book over here. Now, of course, we're refactoring this. We're redesigning it. We don't want to change the behavior. We still want to do this report, but we want to change the design and make sure that we don't break anything. So instead of taking author, first name, last name here, we're going to be taking a person, author, right, and year maybe. In fact, that's got me rethinking year now. What should we do? Probably local date. It was released on January 5th, 1965 or whatever it was, right? Okay. I'm going to leave that as an exercise though, right? Let's go ahead and get rid of this. This dot author is equal to author. There. Cool. What else? I don't need this anymore. Or at least I would have to rewrite it. I don't need author, last name, first name anymore. Why? Who's now responsible for formatting the last name, comma, space, first name stuff? That sounds like an author thing or a person thing, right? Where should person things be? In the person class. That's encapsulation, right? So %s and this dot author. Right? It would be breaking encapsulation for the book class to be doing author things and vice versa. Make sure that you've got a separation of concerns. Right? There, get author, not their first name, but just get the author. This dot author. Right? There. The return type is now a person. There. Everything has been refactored and fixed now, at least in this class. Let's come over here to the book utils class, where we're actually loading up the stuff from the CSV file. Right? There's the author's first name and last name from the CSV file. We have to do that because I'm not changing the format of the file. But now we change the representation with respect to the Java code itself, the Java model here. Instead of passing in first name and last name, what am I going to do? I'm going to create a new author. Author A is equal to new author of author's first name, comma, author's last name, and then pass on that author as the writer or author of that book. You do have to import it because it's in another, not author, what is it? Person, there we go. Confusing myself here. Person P and person. There we go. And pass in P instead. Right? You can call it author if you want to. Right? One of the very few times that you can use single letters here is if it's just a thing and you don't care about what it is. Right? If you want to, I would argue that person is probably better, but it's just as generic. So, and you're not doing anything with it immediately. You're just putting it into this book, and then you're putting this book into the collection so that you can get it done. Again, there's no hard and fast rules on these things. They're just general guidelines. But if you have bad style and it leads to bugs, then it's clearly bad style and needs to be fixed. All right. So over here, let's start at the top and see what's been broken now. Remember that comparator that I was going to sort everything by the author? Well, I can't do that anymore because I don't have a last name and a first name. Okay? But I still want to compare it by author. So you might think, well, I got that getter for the author. Why couldn't I just use that? Right? So here's a book. It's got an author and an author. Herbert, but then it's Frank or Brian. Brian goes first because B comes before F, right? All I have to do is get those authors and compare them, but now it's not a string. It's not naturally comparable anymore, right? So I can't use something simple like this. Instead, what I would have to do is I would have to go back to my original presentation here where we had a full comparator that would then go to the book class, pull out the author, go to the other book class, pull out the author, then go to the author classes, pull out the last name, compare those, pull out the first name, compare those if there's a tie. Right? I want to make sure that my life is much simpler than that. Right? Again, where does person stuff belong? In the person class. So the criteria by which you can compare this person to that person, where should it belong? In the person class. To do that in Java, I'm going to make this implements comparable. And what are you comparing? You're comparing people, person. There you go. You're comparing that person to this person over here. This person, I'm in the class here, and this is a person class. This person and that person. I want to compare them. Let me go ahead and show you what it looks like. Add unimplemented methods. It's already been auto-generated for me down below. We didn't get all the logic, though. We still need to write something for ourselves, right? We're not in Star Trek world yet. Right? Okay, so to understand what this is doing, this is an interface. We'll talk about that later. And it's making this comparable. It's just like a string. A string implements this comparable interface because this string, apples and bananas, I know how to compare those because it's built into the language. It's been done for me. This integer and this integer, it's naturally comparable because I've got 5 and 10. 10 comes after 5. It knows how to do that stuff because somebody came along and implemented the comparable interface. But nobody came along and implemented a person class that implemented a comparable interface so that I could do something like this. See that compiler error? It's now gone. Right? We just need to complete it down here. Right? It looks like this. It returns an integer. What do you think that integer represents? Here's a person, here's a person. It goes like this, this, or this. The same exact pattern that we've been seeing over and over and over again. Something negative if they're in order, something positive if they're out of order, or 0 if they're the same person. Okay? We have to write that logic right here. So that person, by default, it's going to generate O because it just sees it as an object. For now, I'm going to call it that person. I want to compare this person to that person. Who comes first? So look at their last name first. Int result is equal to, well, what is a last name? It's a string. Or here, last name is a string. We know how to compare those because they're naturally comparable. Compare to, right? So this dot last name dot compare to that dot last name. Now, if there's a difference, Jean Aurel, A-U-R-L, or whatever it is, it starts with an A, and then Zoe, right, starts with a Z. If they're already comparable and there's some result here, then I'm done. But otherwise, if they're the same, Herbert and Herbert, now what I need to do is I need to look at the first name. So if the result is 0, then we've got a tie. How do we resolve that tie? We say this dot first name dot compare to that dot first name. And then we return the result. And that's going to give us something negative, positive, or 0, depending on the relative ordering of those two people, or those two persons. Okay? I'm going to compare this person to that person. If you want to, you can go ahead and leave it as that. Otherwise, you can go ahead and refactor it and call it something else. You can call it P, right, for person. I'll just go ahead and leave it at that because I'm comparing this to that, right? By the way, in C, how would you have to do something like this? Write a comparator, write a comparator, write a comparator. Where does that comparator belong? Just out there, right? Why? Because C is not an object-oriented programming language. C, you have to put everything lives in the global namespace. There is not strong encapsulation. There is no person class, so you can't put the person stuff in the person class. What about Python? How would you go about doing this? It's even easier in Python. Pull in a library called total ordering. You annotate your class with the total order, and you only have to implement 2 methods, less than and equals. Right? And it takes care of the rest for you. Okay. Let's come back over here to book demo. That goes away. Right? Let's go ahead and run this and produce these reports for now. Right? I'll go ahead and get rid of the rest because we have other things to fix here. There's the worst one. There's the best one. Oh, I didn't implement. Here, let me go ahead and print my entire library here to show you that it in fact is by rating. Oh, that's not what I want. Let's go by author. I won't get the correct results here, but you'll see, at least for the printing here, Clan of the Cave Bear by Arl Jean at the first. Down here where we've got, let's see, Herbert Frank, but Herbert Frank, there we go. Brian came first now. Why? Because B comes before F. All right, undo that. Now, let's go ahead and fix and refactor the rest of this stuff. Right. I have a much better model here now for my, what do I want to say, for the way that I'm representing data here. Now, instead of creating a dummy book, I can create a proper object, a person object that represents Frank Herbert right here. Right. Collections.sort by author, binary search, library key, and then by author. Ooh, okay. The key here is now a book. Unfortunately, I do have to create a book. Book key, let's say, is equal to new book, and I just want to give it the author, Frank. Let me go ahead and rename that to Frank, because that's what it is. Right, there we go. And here's the book key. Right. Oh, wait. Can I create a book with just an author? Not the way that I've got it set up yet. Remember, I kind of deleted that, that option. How could I restore that option? Let the Eclipse do it for me. Right? Source, generate constructors. Oops, cancel that. Generate constructor using fields is what I want. And deselect all, and I just want the author. Generate that. Done. What's the title? I don't know. It's not defined. What's the year? What's the rating? Not defined. But it also kind of, I've got some repeated code here, right? So to do, maybe refactor this so that you don't have this repeated line. We'll take a look at that later. I'm just going to put a to-do here right now to remind myself of that. That takes care of that line, right? Here's Frank's books, and we can print that out and see what it looks like. Now let's go, I'm sure that it works. Let's just move on to this part though. So, can I now separate everything out into bins? Frank's books goes over here, Ben's books go, or Brian's books goes over there, Jean's books goes over there. Right? Is it right to use a string anymore? Nope. And here is where maps outshine plain old dumb dictionaries in Python. In Python, you can use what as keys? Integers and strings. That's it. Right? Maps, you can do whatever you want. I can map an author to their set of books, or person, I guess. I keep thinking author, it's person. Right? A person will map to their set of books. Right? Now, for each book, I'm going to get that author's books by getting not their last name, but b.getAuthor. Right? That person. b.getAuthor. Oops. There we go. So why is this so much better? Why is it so much better to use a person object than a string object? First of all, you've got more information. It's not just their last name. It's their last name, first name, et cetera, et cetera, et cetera. Right? You don't have the problem of mistaking Herbert Brian for Herbert Frank. Right? And also, the real argument here for why you would want to do this is because it's closer to reality. Right? An author is just is not a string of characters, right? An author is a what? A person. This object-oriented programming way of approaching things means that you're actually modeling the real-world problem much closer than you would be if you just represented everything with a string. Not everything is a string. Not everything is a number, right? Some things are things that you want to be able to reason about and to model in your language. Okay. All right, otherwise, let's see, what else? Now it's not author, and now it's not a string that's a last name, but it's author A, oops, person A, and A, there we go, and we'll print out the person's name, full name, using the toString method over in that class, and then number of books. There we go. And now that it's longer, let's go ahead and pad it out to 20 columns there. There we go. Right. Oops. Something happened. First of all, the report looks nice, right? The report has Gibson, comma, William, and Pratchett, comma, Terry, et cetera, right? So what's the problem here? It looks like every book by every author is being treated by like a different author. Are there two Frank Herberts in this world? I'm sure there are, but are they, conceptually, that's the same guy on that line and that line, okay? Now this gets into something in object-oriented programming where every object has three things. Well, I'm only going to talk about one. But every object has an identity, right? How do you know that this object that represents Frank Herbert is the same thing as this object over here that represents the same person? Right? How would we do that in the real world? In the United States, let's say. U.S. citizens are uniquely defined how? Social Security number, tax ID number, right? Some sort of a unique identifier. Right? We need to bring in that concept and put it into our class here so that Frank and Frank are the same person, right? Let's come over here to person. Every single object that you define, that is defined in Java and that you define, will have a way to determine uniqueness, right? That this object is equal to this object. Now, by default, what we have here is this person. If you create this person and this person, they're the same thing if they're the same thing in memory, if they have the exact same memory address, okay? Unfortunately, there's no way for me to pull the memory address manually. Instead, what I would have to do is I would have to say, get rid of this toString method. There we go. And let's run that report again. Book utils, there we go. Right. There we go. Do you see all those memory? I can guarantee you that each one of those memory addresses is unique. Because when I loaded up the file, or loaded up the data from the file over here in book utils, yeah, here we go. What I did is every time I created a new book, I created a new author, a new person right here. So that Frank Herbert and Frank Herbert on two different books, those were two distinct objects with two distinct memory locations. I don't want that. What I want is that this author and this author are the same if they have the same last name and the same first name. Right? Now, I could go back over here and redesign this so that there's also some sort of unique identifier. Right? For example, a social security number, right? Or a UUID, a universally unique identifier, or a database key, right? If I were going to store this in a database. Whatever, right? For now, though, I'm just going to say that that author and that author are the same if they got the same first name and same last name, okay? To do that, let me go ahead and restore that toString method. Java has a built-in value, or built-in method called equals. Let me go up here and generate hash code in equals and put it right here. Now, the generated code is actually kind of complicated, but let me walk you through it. That object right there and this object are the same if they're the same thing in memory. Right? That's the first easy thing that you can check. Otherwise, if that object is null, well, I exist because I can refer to myself as this, right? So therefore, I'm not null. But if that object is null and I'm not null, then certainly they are not equal because one is null and one is not. Otherwise, is that object over there, is that a person? Right? I'm a person, but is that thing over there a book? You can't compare books to people. And so that's what this is checking. If they're not the same type of object, then they're certainly not equal. Otherwise, it will force this object to become a person, and then we check their date of birth, we check their first name and last name, we check their first name and their first name, and then their last name and their last name. If you only wanted it to be based on first name and last name, you can go ahead and do something like that instead. In fact, when I generated that, I think I could have chosen that option, didn't I? Go up to generate equals in hash code, and yep, I don't care about the date of birth. I just care about the first name, last name. generate that code, and it would have generated it a little bit differently. Right? Otherwise, if your standard is, like, say, a social security number instead, private int social security number, then you would have generated an equals and hash code method based only on the social security number. Okay? Otherwise, this is good. Now let me come back over to the book demo. This probably will solve my problems. I'm crossing my fingers now. Right? Did it? All 6 of those books by 6 different instances of Frank Herbert that were the same author. Yep, it fixed it. Not only that, but Frank here only has 6 books. Where is Brian? There he is. He's different. He has 1 book. Right? He has a lot of other books, but in my database over here, he's only got 1 book. Right? Haven't read any of them. Okay. All right. Any questions so far? No? All of this, let me reformat this. Models a book. Let's go ahead and go over to here with a person. Reformat this, represents a person. That's an A-level class right there. That's an A-level class right there. All right, and this has a lot of cleaning up to do. First of all, should you leave to-dos in your code? No. I'm posting this later to the notes, so I'm going to leave these in here for you to understand what we're doing. Right? But that does not belong in your code. That's called cruft. Right? We've talked about cruft before. Right? The cruft haul, it filled up with garbage because nobody wanted it. Don't do that. Don't fill stuff up with garbage. Take it to the recycling center. Right? All right, so to-dos should not be in there. This is in there so that you can see what a traditional comparator looks like versus this more modern convention here. Let's see, what else? I would probably put this into its own function to do a report. I would probably put this into its own function over here in the book utilities that it loads it up from the file and then gives you directly this kind of a map over here. And I would probably put this in its own function as well. Right? Separate things out. Right? All right. That's all I wanted to do on this demonstration. Any questions? All right. So then, as a recap here, and we'll come back and do another demonstration on Wednesday after the technical writing. But otherwise, again, the points that you should be taking away from this first initial demonstration is that Java is a class-based object-oriented programming language. Everything in Java is a class or belongs to a class. Those are the first questions you should be asking yourself. Here's a problem. What classes would model this problem? Right? Here's a class, here's a class, here's a class. Okay. Now how do I bring those classes together to produce that report, to produce that representation of data, to do that thing over there, right? Your objects should come first, right? Your unit test should come first, but then your objects, right? It allows you to model a real-world object or entity, right? That's what a class is in Java. It allows you to group multiple pieces of data together into one logical unit. It also allows you to encapsulate methods that act on that data or on that data's class, i.e. its functionality. That's the last thing I want to do before we leave today, and we'll come back to that in a second here. Otherwise, it allows you to group functionality together with the data that acts on it, etc. Right? We'll come back to this on Wednesday, but what I want to do is I want to really drive this point home first. Right? Let's come over to this book class again. Oops. Come on, just take all that away. There we go. Let's see, where's my book class? There we go. All right. So I am representing this by a year. Let's now refactor that idea that I told you that let's go ahead and replace that with local date, right? And I'll call this release date. There we go. And import that. Now, instead of taking a year, I'm going to take a local date. I'm refactoring this yet again. I'm changing how it works. And then release date is equal to that release date is equal to that release date. I've broken a bunch of other stuff over here. That's fine. Let me show you how to create a date. Local date release date is equal to local date dot of, and it was released in that year. 00. Right? This is year, month, day. Is there a valid month that's 0? How do we count our months? from 1. So I don't know what the actual release date is. So for all of these, I'll just say that it was January 1st of that year. Okay? And there's my release date instead of that release year. Better way of representing this. Okay? Is that the only thing that breaks? Yep, that's the only thing that broke from outside so far. Right? All right, what else? In, not this year, but in this dot release date dot get year. There we go. I can get the year out of it, and I'm not going to get this year, but get release date, and return this dot release date. There we go. That all looks good. Very, very minimal change here to have a better model. But what does that enable me to do now? How old is Dune? Dune was released in 1965. It is 2023. That math hurts my head. Let's let the computer do it. All right? How many years old is it? Let's go ahead and write a function to do it so that we solve that problem forever. First of all, where would that function exist? Maybe over here in book utilities, right? Public static int get age of book in years. There we go. And I'll take a book B. Right. That's functionality. That's a feature. That is behavior. Right? We call that behavior in object-oriented programming. It's behavior that acts on what data? Today, right? And the release year and the difference between them. Right? So where is the release year? In the book, right? So where should this functionality be? In the book class. If I put it here, I'm breaking encapsulation. I could do it this way. What I would have to do is I'd have to take the book, rip it open, pull out the year, pull out the month, pull out the day, then do my mathematics and say, okay, well, also today is 2023, so 2023 minus 1965, it's 50 some years old. Right? Where does that stuff belong? In the book class. Where does figuring all that high-level math out for computing a square root function belong? In the square root function, right? That's the whole reason I defined that. Somebody defined that damn thing so I don't have to worry about it anymore. The whole reason that you put stuff in classes is so that you can reuse it and not have to worry about it anymore. Public int get age, right? In years, right? And this is our first non-trivial function. Therefore, it requires some documentation. I'm not going to call it get age in years. I'm going to put that into the documentation. Returns the age of this book in years, right? According to the current day. That tells me how, the documentation tells me how it works. Now here's how you do this. Local date today is equal to local date dot now. There. Now that's a relative term, right? When the computer actually executes this, it'll be now, and then when it executes the next command, it'll be later, right? 1 nanosecond later. So what does that actually mean? We don't need that much precision. That's why I'm only doing this in years, right? What does now mean? Well, what if I reset my system clock to be 5 days from now, right? Then that would be now, right? All this is doing is getting the current system time according to the computer that it's on. If I took this and moved it halfway across the world where it's a different day because of date times, right? How date time works on the globe, then it's going to be different there. It's a local, that's why we call it a, that's why we don't call it a date. That's why we call it a local date. Right? There's today, let's say today, or no, this dot release date dot until today. That returns, what does that return? I think it returns a duration or a period. A period. All right, so period p is equal to this. And I'll pull that out, java.time library. There's a difference between a date time, a date, which represents one point in time. A period represents a start date to an end date. There's also an idea of duration. 5 seconds versus 2 hours, right? Which is different than this. You can convert a period to a duration, which is what we're essentially doing here, but p.getYears, there we go, and return that. There. Right. Now let's come over to here to the book utilities class, or book demo here, and let's print out the entire library again. There. But let's also append to it the age. Age is percent or plus b.getAge. There. Let's come all the way up here. Worst, best. There. Harry Potter and the Deathly Hallows is 16 years old. Right. So it came out when many of you were children, maybe? I don't know. Wise Man's Fears is 12 years old. Yeah, it's been 12 years since he's promised the third in that series. Game of Thrones predates probably many people in here, even your birth date here. It's 27 years old. Where's that Dune? Dune. There we go. It's 58 years old. Where did that logic belong? If it's doing book stuff, the age of a book, it belongs in the book class. What if I wanted the age of the author? Author class, right? What if I've got a bank account and it was opened on a such and such date? Where does that stuff belong? Book, or in the bank account class, right? Book stuff belongs in books. Author stuff belongs in person, et cetera, et cetera. You separate concerns and you don't mix them. All right, we'll continue there next week.